Ladies and gentlemen, let me welcome you very warmly to this webinar on solutions for reducing India's coal use for power generation and the role of biomass in this context. My name is Christian Rakusch. I am president of the World Bioenergy Association. Our association is an association both of corporate members and of other associations dedicated to bioenergy. And our role is really networking around the globe, providing information on how to use sustainably bioenergy in the best possible way. So that is our mission: bring people together, bring experts together, join experiences that are available in some parts of the world and not yet available in other parts of the world to create a value added. Let's come to this specific webinar this afternoon. India is using about 70% of coal for its power generation. And obviously, in the long run, this is not compatible with a view of net zero, of reducing the CO2 emissions. And the question is, how can this be changed? Another pressing environmental problem in India is also the burning of agricultural residues in the fields that is creating a tremendous amount of air pollution. So these two aspects have both kind of provided the reasoning for mandating to replace 5% of coal with biomass by the year 2025, and even increasing this mandate to 7% 2 years later. Now, for the time being, it seems like we are still quite far away from even moving close to this target. And the question is really, how can we bridge the gap between this very significant ambition, because 5% may sound little, but it is a lot. It is using about 40 million tons of biomass, almost as much as large parts of the world are currently producing in pelletized biomass in total. So it is a very ambitious goal. And the question is, how can we achieve that? We have invited a number of excellent experts to bring their views on how this can be done, what needs to be done, what the barriers are, and where we need to go. And I would like to first invite very warmly Dr. Sanjay Kumar Sahi from the Ministry of New and Renewable Energy. Dr. Sanjay Sahi, the floor is yours. We can see the slides all right. Please unmute yourself.
Yes, thank you. I am Sanjay Kumar Shahi. I am scientist in the Ministry of New and Renewable Energy. Next slide, please. See, not only our ministry, but the whole of Government of India has been making efforts to, in some way, come together and do things which will ultimately achieve our net zero targets. So by 2070, we have to achieve the net zero target. And of course, renewable energy is playing a big role in that. And among the renewable energy, biomass is one very important thing which we need to do. And the Ministry of New and Renewable Energy has taken the lead in this direction. And we have come up with a lot of things. One by one, I will try to explain what we are doing. So in this slide, you can see this is an overview of the biomass potential in India. We engaged ASCI, the Administrative Staff College of India, Hyderabad, to prepare a report on the availability, what are the different type of biomass available in the country. So in March 2021, ASCI submitted a report. And the total biomass that has been assessed is 754 million tons, and the surplus biomass is 228 million tons. And the bioenergy potential has been estimated at 28 gigawatts. Next. The survey was conducted in 254 districts of India. The potential from biomass has been assessed from 54 different crops. India has a geographical area of 328 million hectares, out of which the net cropped area accounts for 45%, that is 147 million hectares. And the total biomass production per annum is estimated to be 750 million metric tons. And that surplus is again, as I told you, is 228 million metric tons. The high potential biomass potential states in India are Punjab, Uttar Pradesh, Gujarat, Maharashtra, and Madhya Pradesh. Next. Next slide, please. And the study, crop-wise study was also done. And as per the study, the biomass potential in India, if we take just 7 of the crops put together, comes to be 75 of total biomass potential. And those 7 crops are rice, cotton, wheat, maize, potato, coconut, and banana. And if we put together another 4 of the another 4 crops, that is sugarcane, oil seeds, arhar, that is we call arhar dal here in India, and castor. These 11 together have a potential 84% of the total biomass potential in India. Next. And based on the study done by ASCI, there is one institute under our ministry called National Institute of Bioenergy at Kapurthala, Punjab. They have developed a biomass atlas. And this atlas presents the state-wise total and surplus biomass availability in the country, state-wise and crop-wise surplus biomass availability for different important crops, state-wise and crop-wise fractions of different residues available per crop for various important crops. Images. The atlas also provide easy access and understanding of the Indian bioenergy availability scenario. You can see there is a link you can go through and see the different things that are available on the atlas. Moreover, they are working more on it, and more things will be added in future. Next. And our ministry, the Ministry of New and Renewable Energy, has been providing incentives in the form of subsidy for biomass generation, bio-CNG generation, biogeneration based on biogas, power based on bio, and agro-industrial waste. Then biomass gasifier. The CFF return, as you can see, for biogas generation is 0.25 rupees 0.25 per 12,000 cubic meter per day. Then for bio-CNG, it's 4 crore per 4,800 kg per day. And for that is for new, if you are going to set up new biogas plants, bio-CNG plants, and 3 crore per 4,800 kg per day for existing biogas plants. Then also we have provision for power generation based on biogas, that is 0.75 rupees 0.75 crores per megawatt for new projects, and 0.5 crore per megawatt for the existing biogas plants. Then also for power based on bio and agro-industrial waste, we provide 0.4 crores per megawatt. And for biomass gasifier, putting up a biomass gasifier is 2,000 rupees, 2,500 per kilowatt hour equivalent, and 15,000 per kilowatt hour equivalent with 100% gas, biomass based gas engines, and rupees 2 lakh per 300 kilowatt hour ton for thermal applications. And for northeastern and special category, we states the CFA or the central financial assistance 20% higher. Next, please. And we also provide CFA for briquette and pellet manufacturing. The minimum eligible capacity for a plant it will be 1 TPH, and the rate of CFA is 9 lakhs per TPH, with a ceiling of 45 lakhs. And for biomass non-bagasse cogeneration plants, it's 0.5 megawatt. Minimum is 0.5 megawatt. The plants would be of 0.5 megawatt capacity, and the rate of CFA is 40 lakhs per megawatt, limited to rupees 5 crores per project. Next, please. Yes, the briquette or pellet manufacturing installed capacity is 420.6 million metric tons per hour, and the quantity of biomass required per day is 3,364. For non-bagasse cogeneration, the installed capacity as on date in India is 10,355 megawatts, and the quantity of biomass required per day for these installed projects is 82,842 tons per day. For bio CBG based plants, the installed capacity is 1,753 TPD, and the biomass required per day is 28,303. So the total biomass required per day for these plants is more than 1 lakh TPD. Next, please. And apart from what our ministry is doing, Government of India, other ministries too have been mandating things for the, especially for the Ministry of Power. They have come up with the co-firing policy, as already Christian what mentioned earlier during the start of this presentation. So Ministry of Power, they have come up with a co-firing policy for thermal power plants and are mandated for 5% co-firing through biomass pellets. Moreover, for if these plants they do not utilize biomass, for non-utilization of biomass in the capital, national capital and adjoining areas, there is a provision of imposing environmental compensation. So environmental compensation will be imposed by the Commission for Air Quality and Management in NCR and adjoining areas. So that penalty is also there for these thermal power plants. If they don't utilize the mandated biomass for co-firing, they will be penalized also. So because of these efforts, mandates on the national level, the requirement of torrefied pellets for achieving 5% co-firing, as on date, the required is 5% co-firing in different thermal power plants. So for torrefied, the requirement is 11,000 tons per day, and that for non-torrefied pellets in the country is approximately 90,000 tons per day. So we are still quite, lagging in that. But then we are doing our efforts. The ministry, though we are currently having a provision of providing CFA, we are going to enhance that so that more and more pellet plants, we get proposal for setting up of pellet plants, so we are able to produce that much of required quantity of pellets for at least for the co-firing of the thermal power plants. Next, please. Thank you. Thank you. My presentation ends here. Thank you.
Thank you very much, Dr. Sahi. At this point in time, let me reiterate that if you have questions to the presentations that are being made, please feel free to use the chat to bring your questions to our attention. I have already got two questions to Dr. Sahi. The first one was, what are the main issues that cause this mismatch between the needed supply and the currently available supply?
Yes, we have found that due to our scheme, our subsidy scheme, initially, right now, the scheme we have is for both briquettes and pellets. But most of the proposals that we are receiving is for briquettes. And then we did a study and found out that the cost of the pellet manufacturing machines is higher compared to briquettes manufacturing machines. Maybe this was one of the reason why we did not receive that much of proposal what we expected for pellets. And just because of that, now we are in the process of revision of the CFA, and we expect once it is revised, more of pellet manufacturing proposals will be there, and will be able to meet the required quantum of the pellet production will be there. So we are doing our efforts. Yeah.
Another question was regarding the penalties. You mentioned the penalties. Are the penalties currently at a level that really disincentivize not to comply? I mean, you always have costs of compliance, and the question is, if the penalty, paying the penalty is less expensive than complying, you may be kind of persuaded to rather pay the penalty. So can you comment on that?
No, it's not like that. There are certain, like if you are using this much of percentage, the penalty below this much of percentage, penalty is this. So there are different layers. So different percentages are fixed. If you are using less than that of percentage of biomass, you will be penalized with this amount. So it is there. Uh, and what report we got from the Ministry of Power is that they are using the thermal power plants, have started using it, and they are complying with the directives as of now.
Brilliant. Thank you very much. Thank you very much for your contribution. And then I would like to invite as our next speaker, Mr. Biswajat Datta. He is Vice President of SAEL India. You are actually active in developing biomass power projects. Can you tell us about your experiences?
Certainly. Thank you so much. Thank you so much to the World Biomass Association for giving us a chance to a company called SAEL Limited. Greetings to Dr. Sai, Mr. Bharadwaj, Alejandra, Dr. Chaturvedi, and all the peers who are listening to us from this particular forum webinar. A quick introduction, sir. Yes, we are a very young company in India, and very proudly we are pioneers in the field of biomass throughout Asia and world. Perhaps the first country to utilize the best technology available in Europe to convert 100% paddy straw into energy. Today, when I talk to you, we have collected around 1 million tons of agriculture residue, especially straw, which is one of the most pressing concern in north of India during the course of stubble burning. We are operating around 75 megawatts of biomass plants scattered across Punjab, Haryana, and Uttar Pradesh. We are at a very final stage of commissioning of 6 projects more in the state of Rajasthan. And we are also in discussion with other state government so that we can utilize their experience the challenge which has been faced by the other industries as clearly mentioned in the paper which has been circulated to everybody, as also mentioned by Dr. Sahi and also Dr. Christian by you. Significantly, what we can tell you is that our success story has been dependent on the technology, finance, and logistic control. Biomass per se is just like, the radiation which is available in solar or the water which is available for hydro energy. In case of river, if the river is flowing, the first thing you do is to create a dam to generate electricity. We particularly targeted the areas where a lot of agriculture residues were there. The agriculture practice in India has been in a developmental front. We are now a developing country, and our farmers are also hands in hands with technology. Today we collect, as I said, last year we collected 1 million tons of stubble to use them, store them for generating electricity. We do keep a tab on what Government of India, because Government of India has been trying to push in the schemes to co-fire with the coal to reduce the carbon reduction net zero in 2030, 2070. So what have we done? We have really done. Today, when we talk to you, sir, we bring in the best of technology. We bring in the best of funding agencies. Today, our trust is not only the Indian bankers, the financial institution. Today, we are supported by ADB. Today, we are supported by DFC. Today, we are supported by Norfund. These are the companies who have trusted on us. They have seen on ground what we do. And today, when we say that, we have one of the largest plants, which is a 20 megawatts. And with the technology available, we will be putting up plants not less than 45, 50 megawatts in one shot. There is abundant of biomass available across states. India's agriculture state, a lot of wheat, a lot of rice, a lot of maize, a lot of lentils. You name them and you get it in India. We have projects running from 2009 onwards, where we have used around 24 different kinds of agriculture fuels available. But we have stabilized. The technology is stabilized now. We proudly say that the PLF of a plant, which gives the round-the-clock power to the grid, is around 87% plus. Very proudly say that. And having said so, what I would like to say is that biomass per se is a subject which is not being taken very seriously in any forum or any government per se. But the reason why we are able to succeed in this particular field is that we have been able to maneuver the logistic and the storage part of the biomass, which is a challenge in palletization as well. We have empowered the farmers. We have empowered them. We have done a social development. Today, my company is strongly built on the ESG platform. We ensure that the socio-economic development of the areas, the rural areas where our farmers are there, who gives us food, and from them we convert them into energy, are developing at the same time India is developing as well. We have, for our success, we have tied up with international companies, and we have seen that how the practices are being done in different parts of the world. Companies have come and have supported us. We have given them systems so that they can collect the residue, and by collecting the residue, we can use them for generating power at our power plants situated across North India. So to be very important aspect of this particular forum is that India needs to reduce the pollution created out of coal, and we need co-firing with a pelletization with pellets, non-torrefied or torrefied pellets. It's a good step. It is always a good step. But at the same time, biomass per se is the low-lying fruit. People have to look into that as well. We say that we are capable, the company SAIL is capable of putting up plants of more than 1,000 megawatts in this country, which also should be given equal importance. Pelletization, yes, a lot of startups, a lot of new development, new technology coming up that will certainly go on, hands on hands. But having said so, we have been trusted by everybody. Some states, the other states will follow through. And we are open that we will be able to take our technology, our experience, across the globe and develop biomass plant, not only to generate power to give RTC, develop the rural areas and power the farmers, but at the same time showcase that this is one of the important subject to, to put a challenge on the stubble burning across the globe and also in India. Thank you.
Wonderful. Thank you very much, Mr. Biswajit. That's a very encouraging message, and congratulations to your success in actually developing projects. There was a question from the audience regarding one of the key issues, and that is, I mean, the availability of residues is very seasonal. How do you deal with the challenge of storing the material to provide the fuel for a power plant throughout the year? Do you immediately pelletize it? Do you bale it and put it in piles? How do you deal with that?
So a success mechanism has been very simple, Dr. Christian. Wherever we have envisaged or wherever we have our power plants, especially let's take an example of Punjab. Punjab is a very agriculture-rich state and the most rice-producing states in the country now, to everybody who's listening to me. So we have 4 operating power plants in Punjab. So if I select a power plant, I also select the vicinity areas, a radius on which I have to operate. Because at the end of it, the viability of the project is important. For 55 to 60% of the cost which I get for the power I generate is given back to the society, to the farmer per se. So what we do is we not only talk to the farmers in terms of the FPO which are available, through which we have empowered them. We also help get them the equipments, which are balers, the systems, the tractors, the heavy tractors, and then talk to them about leasing the land for storing our raw material, our fuel. So there are few pockets across the plants where we will select few places and we will store it in a very mechanized and the most modern way, so that the moisture contents due to rain and all are totally challenged and they are not taken care of, well taken care of. And at the same time, then what we do is then we have a mother stored plant in our yard, in our power plant as well. So today from 25, if people know about how biomass is converted, we bale them. When we started baling them, it was around 25 kgs of bale. Today we are doing roughly around 0.5 tons, 500 kgs of bales, which are very compacted. It can be easily transported. But still, these are the things which reduce. In Punjab, the cycle for the next crop gives us a window of only 30 to 45 days to collect it and store it. That is where my team on ground, our team on ground is very active. We have done all our homework just before the harvest season starts. We collect them, we store them, and as per the requirement, we keep on pushing it to our mother plants to generate electricity.
How do you protect the raw material from water, from rain?
So see, we certainly the boilers are so designed that we have to maintain the moisture content in the fuel. We don't allow the moisture content to fall below certain percentage because there are some reaction which can take place and it can self-ignite. At the same time, we also see that it doesn't go beyond 20%. So there are, when we say that when we choose a piece of land, a barren land of a farmer's, which is lying redundant, we create a platform over there. We will create a height over there, and then we cover it with the best material available. So there are certain heights which has been decided by the fuel team, which are easy to maneuver, easy to manage in terms of logistic, in terms of moving it from one place to another, and suddenly cover them up so that they are not destroyed or taken care of the rain which are available out there.
And do you then use the bales directly in the power plant?
Yes.
So there is no pelleting in between?
There is no pelletization required. That's what I'm saying, that the fruits are there. We just cut the fruit and eat it. We don't need to convert it into pellets. No need to convert them into other briquettings or something. We directly put it in the conveyor belts, and those directly goes in the boiler for combustion, and we generate electricity out of it.
And that is because you have dedicated straw boiler plants,
Yes.
which is a different situation than a power plant that would co-fire, because in that case, you need to deal with a completely different combustion system, correct?
Yes, correct, sir. Correct.
Very well. There was one more question that was asking how is the situation for financing? I mean, you are investing into plants. Do you find it difficult to obtain financing? Is this something that other developers might find as a challenge and as a barrier to develop more co-firing projects, or how do you see that?
Yeah, I can certainly throw lights in terms of what happens when it comes to financing a biomass power plant. It is certainly one of the most not so easy financing project for any financial institution or bank because of the type of capex which is required to build up a power plant. The biomass power plants are expensive when you use the best of technology, and best of technologies are available. And if you use the best of technology, you pay more, but at the same time, you rest assured that you are pumping in at a 85% plus PLF to the grid, which is also very important, as everybody knows. Dr. Sai is here, and he also understands that how important it is for grid stability to have RTC. So financing was an issue for us. We started, as I tell you, we started way back in 2009 when two of our plants got commissioned by 2 years' time in UP and Punjab. Those were the time where the technology was very nascent. We were trying to locate the boilers available different parts of India or maybe different parts of China and Europe, and we zeroed down into something. Having done so, we were very active in the agriculture sphere as well. When I talk about you, my country is energy and food security company. We do a lot of milling, rice milling, and we had that sort of a channel to use and utilize it to have a financial backing from the bankings. But having said so, when we started doing in a big way in 2015 in Punjab and Haryana, we were also trying to showcase and get the technology from Europe. And when we were trying to bring in there, the bankers who were looking at us and who had seen our experience were more than happy to come and join hands with us. Today, when I talk to you, my Rajasthan projects are being funded by ADB, first in its kind in India. ADB will normally not do any projects in biomass until unless they have complete trust in it. And our trust has been our projects which have been running and operational for past many, many years. It is a challenge, but we did take up this challenge. We did take up the challenge of logistics, and that is how we are successful today. Yes, my point of word to the people who are trying to put up plants, pelletization plants, or maybe biomass plants itself, because we need people who should come up, look it to us, and also help us learn at the same time that we have opened up a channel for them. They can have a discussion, and based on that, they can get a project finance from different bank institutions.
Let me ask you a question. I did not fully understand I understand there is a mandate for the coal-fired power plants to co-fire. So in a way, they have to do it, and that creates an economy of its own. But you're doing standalone power generation with biomass, which is inherently more expensive than generation with coal. How are you able to do that economically?
See, today, what has happened is that India also works on a certain principle called RPO, Renewable Purchase Obligations. The regime is changing. We started way back in 2009, 2010, 11, where the RPO was clearly divided in mandate for solar, wind, biomass, and others. So there was always a mandate to the discoms who are operating in different parts of the states in the country to have power also procured from biomass. And it was there, and it's still there. That is one reason why we were able to do it and convince the discom. And yes, the challenge is it is an expensive power compared to solar, but at the same time, it is an RTC. It is not like a wind or a solar where you just do it for 8 hours or 4 hours or 6 hours. It is round the clock. It's round the clock. And when I say it's round the clock, I'm giving stability to the grid as well. At the same time, the cost is two-factor over here. One is the fixed cost and one is the variable cost, just like the coal-powered thermal power plants, because there is a fixed cost and also the cost of the coal. So over here, the variable cost is directly linked to the farmers. The states who understand it, who have abundant agriculture residue available, they have come forward. They have done the analysis in terms of what is the cost of the project. And once they were convinced and once we were able to give them the trust that we are going to operate it for 25 years, we are going to generate loads of employments. We are going to empower the people, the local people out there. We stand separately and in a successful mode for generating biomass, directly power from biomass. That's been a mantra.
That's a beautiful success story. Thank you very much for sharing that and also sharing the experiences you have in building this up. With that, I would like to move over to our next speaker. Vaibhav Chaturvedi is going to talk to us about the challenges that the net zero approach poses. The floor is yours.
Great. Thank you, Christian. A very good afternoon to all the panelists and all the colleagues who have joined us today. I'll just share my screen. Great. Yeah. So I will be talking about the implication of net zero for India's power sector. So essentially, till now, a lot of discussion has been kind of fairly technical at the level of bioenergy. I'll just step back and take a look at the larger picture. A bit about my organization. I come from the Council on Energy, Environment and Water. We are one of Asia's leading think tanks in the climate space. We work across many areas of work, which talk about things as varied as power markets, industrial sustainability, livelihoods in the agriculture sector, as well as aspects related to clean air, sustainable water, food systems, quality, cooling, mobility. Also some enablers like finance is a very important part of the debate, international cooperation, climate resilience. And we are close to 300 people now and we are based in Delhi and also have an office in one of the states in India, Uttar Pradesh, but also work across many states. Essentially, we are a think tank who work closely with the various ministries of the government and also various departments of the across many states in India. So that's what CW does. So I'll start with this big picture of India's emissions trend. Where are we going in the business as usual scenario? And this is from one of our studies. I lead the long-term modeling work at CW, essentially looking at scenarios 30, 40, 50 years from now, that given the current state of technology evolution and the best current understanding and the state of policy, where do we think we are moving in the future? So this is an emission chart across of carbon dioxide emissions across sectors from India. Power sector is the biggest. There's a lot of discussion today has been about power sector, the coal use in the power sector, which of course we know India's power sector is dependent heavily on coal. Almost 50% of India's CO2 emissions from the energy systems come from the power sector. And then the second biggest is the industrial sector, then transport, and then buildings, and then some other sectors. So largely, we see the curve growing very fast. And a very important reason is, well, India is a fast-growing economy. So as the economy grows, there is a significant demand of services like air conditioning services, for example. That leads to heavy penetration of air conditioner, increasing electricity demand in India. Also, a lot of penetration of cars. So people are moving from two-wheelers to cars in a very big way. So a lot of transformation is happening in India, and this is the result of all that transformation. This kind of perennially increasing emissions from across sectors is essentially, in a big way, a result from India's economic growth story. This already factors in the efficiency gains. So just to clarify, this does not mean the efficiency is fixed. Where efficiency of technologies across sectors, be it cars or be it air conditioners, be it industrial appliances, all of that is increasing. But even after factoring all that efficiency increases, we expect to see a significant increase in emissions. And this is what is not compatible with the net zero future. So the Prime Minister, our Prime Minister announced the net zero 2070 target for India. That simply means somewhere between 2040 to 45, this ever increasing curve has to start bending and reach the x-axis in 2070, something like that. So that's a big shift for even 30 years down the line, India's economic growth, of course, will be lower because it will be a much more richer economy. But at that point is when the decoupling, very fast decoupling has to start happening. Coupling is a continuous process, which means GDP is increasing, but emission increase has to be slower than the GDP. So that's the decoupling I'm talking about. But post 2040, 45, the decoupling rate has to be a very fast, right? So that's the larger backdrop. And we analyzed some scenarios around net zero. So this next graph is about a bunch of scenarios that we explored, looking at the long-term view. So this first graph is about India's electricity generation across very different scenarios. Now, there is a lot of information here, so I'll just quickly summarize. The line which is at the bottom is the reference scenario, or as we know, the business as usual scenario. So this is not net zero, right? So even in a scenario that is not a net zero scenario, we are expecting a lot of electricity increase to happen, right? Because our current penetration is very low. So this increase is kind of very obvious, right? Now, all of these other lines which are bunched at the top, all of these are essentially various variants of 2070 net zero scenarios. So all the four lines here. So different technology mixes. Some will have heavy penetration of carbon capture and storage. Some have heavy penetration of hydrogen, but basically different technology mixes. But all of these are 2070 net zero. Now, what is the big change difference between the bottom line and all of this is that in a net zero scenario, we are seeing a heavy increase in electricity even compared to the BAU scenario. So even BAU is very high compared to the current numbers, but net zero is even double that of BAU in the long-term future, right? And this is happening because a lot of sectors in India have to be electrified, end-use sectors. For example, we are seeing rapid transformation already happening in the private mobility, like electric cars, electric two-wheelers, three-wheeler segment, electrification is already happening. In India's industrial sector, less than 20% right now is electrified. So industrial energy use, less than 20% is based on electricity. That is because electricity is very expensive and coal is much more cheaper. So a lot of it is coal-based, oil-based, 80% plus, right? Now, all that or a large part of it has to be electrified. There is a significant role of hydrogen, but only in specific kinds of industries and applications. So it's not that 80% of India's industrial energy use will move to hydrogen. That is not the expectation. Maybe 20% or so will move to hydrogen, but 75-80% will end up being electricity. Now this is exactly what it leads to, this significant jump as compared to BAU, in the net zero scenario. So rapid increase in electrification. That's one way. And the big result comes from our modeling is solar comes in a big way. So just to clarify here also, because this is a discussion on bioenergy. So when we do these modeling assessments, in fact, a lot of information is coming from many agencies. For example, solar developers, wind developers, NTPC has informed its own assessments of what could be the cost of a new investment in a coal-based power production facility. So a lot of this information essentially comes from experts from the industry. And our understanding is that biomass-based electricity production is kind of pretty expensive. So let's say in absence of policy, the generation cost will be somewhere around 7 rupees in terms of Indian units, 7 rupees per kilowatt hours, as compared to even nuclear, which is as of now 6.5. Coal is 4.5, or solar plus battery is also around 5.5. Without battery, solar is a lot cheaper, right? So given these sort of cost dynamics, and I think that is very important for our discussion today, that even at the individual level with policy support, there is a great role, a very, very important role for bioenergy-based power plants, but also co-firing of biomass in power systems. That is very important. But when we look at the larger picture, because it is as of now also, the comparative costs are kind of pretty high. That's why we see a lot of movement towards solar happening in all the net zero scenarios. This also means a lot of impact for land footprint. A lot of innovative strategies have to be devised. Efficiency of solar panels have to increase significantly. Only then this is possible. But this is what we are seeing. What happens to coal? Because coal is the fulcrum of our discussion, and we are talking about bioenergy replacing coal. Irrespective of the scenario or 2070 net zero scenario, we see coal has to be phased out. The brown line is essentially scenarios where there is no carbon capture and storage. So that's why you see a rapid phase down of coal. If CCS is available, well, you could say some coal can continue to exist in the system for some time. But if carbon capture and storage becomes economically viable, but the long story is coal is expected to go down if we have to meet the 2070 net zero target, which the country has promised, coal will have to go down sooner or later. We expect it to continue to increase for the next 10, 15 years because the development requirements are extremely paramount. But beyond that, it has to start declining in a very fast way. And then, of course, there are other technologies. I'm just giving a snapshot of nuclear energy. This research paper is already published out there. Happy to share if needed. So a lot of other information is there, but nuclear energy is also going to play because this is the only base load source of if coal goes out, wind, solar are variable energy. So nuclear is the only, for the base load perspective, for grid stability perspective, nuclear becomes a very important source, right? So this is kind of a big snapshot of technologies. We are seeing biofuel role, the role of biofuel, especially important in the liquid biofuel section. That's where we are seeing a lot of traction for biofuels happening, as compared to grid, where it will play a role, definitely an important role in pockets. But I'm just giving you a large picture of a longer term kind of view of how electricity system uh, is expected to kind of develop in our view. This is my last slide. The notion of economic trade-offs is very, very important. And this is true for every technology, be it biomass, be it coal, be it nuclear, wind, solar. This trade-offs is very important. And one big trade-off, and I'm just giving an example, one big trade-off is the power pricing. For example, as I said earlier, India's industrial energy use is heavily fossilized. Electricity share is very low. The reason is we know there is something called cross subsidy of electricity in India's policy regime. So essentially, industrial and commercial sectors, the power prices are very expensive, whereas the power prices for agriculture and residential sector, household sector, are very low. They're subsidized. So there is a cross subsidy in the system. There is no way, if we continue to have this kind of high prices for industrial sector, that industrial investors will go for electricity as a fuel because it is very expensive. Coal is very cheap, right? So if net zero has to happen, there has to be at some point of time, sooner than later, very deep structural reforms, which are essentially power pricing reforms. Electricity for industrial sector has to be made cheaper. Because if it is not made cheaper, then either you will force industrial investments to be uncompetitive, or net zero will not be achieved. So nobody knows the future. So when we do these kinds of long-term modeling assessment, it is not that we know the future. We are very clear nobody knows the future. It is just these kind of insights that what needs to happen to achieve a particular goal is what we are trying to derive from this kind of assessments. So it's very clear if power pricing reforms don't happen, achieving net zero is going to be very challenging. And if power pricing reforms happen, that means hopefully the challenge with India's distribution sector, which is perennially in a financial mess because it is not able to recoup its investments. It is always suffering losses. The hope is that with power pricing reforms, the burden on distribution companies, the financial burden, that also eases out. So there are basically some market-based pricing architecture happens. And if that kind of thing happens, it is a great setup for the power ministry to start giving higher incentives for technologies like biomass and biopellets, right? So that's why I want to link with this sort of macro picture of policy, the macro picture of reforms, with what a technology can, how a technology can, or technology futures can be described. That link is very, very important. The more, the more leeway our power ministry and the fiscal space that we get because of reforms or power pricing reforms, the better it is for niche technologies like bioenergy pellets to have their higher penetration in the system, right? So this is very important notion of reforms. The last point I want to make, the narrative of economic transformation is absolutely important, right? So I think in the last presentation also, Mr. Datta talked something very, very important, that the notion of employment, the notion of, some impetus to the local economy. Those are very, very important notions. As an institution, CW works across more than 20 states of India. And just giving an example, in Bihar, for example, which is one of the states in the eastern belt, India's eastern belt, investments in Bihar are flowing in a big way in the biofuel economy. And that's very interesting. So the government is saying this is like one mantra for the state's economic growth. And there's a decent amount of water available in this belt of India. There is a lot of agriculture production happens. Farmers' livelihood depends on it. And if this kind of, if biofuel economy is created in that state, it will be heavily beneficial for farmers. The, the interesting part in liquid biofuels is they are kind of cost competitive, because the price of liquid biofuels is also linked to the oil prices, which are kind of high. So it's an incentive. There is no trade-off, fiscal trade-off for the government to push biofuels. Whereas in the electricity sector, there is a fiscal trade-off because if solar plus battery becomes very cheap, and let's say bioenergy based electricity is 25%, 30% higher, then of course for a developing economy, it becomes challenging to provide incentives because many people will ask this question that why provide incentive for a technology that is so expensive? Do provide incentive for to some extent, but don't go full throttle. Those kinds of arguments will always be there. That's why this notion of economic transformation matters. And many coal dependent states that are moving away are looking for an alternative economic paradigm. Then they have to look for an economic paradigm. It could be a tourist based economy or it could be a biofuel based economy. So the moment we kind of marry these technology futures and these kinds of opportunities with an economic transformation framework, we have seen a tremendous uptake in the state level policy discourse. So we don't talk about just a decarbonization story. We actually talk about an economic growth and development story. And that's where I think the buy-in becomes very, very good. And that's where I think for biofuel or bioenergy electricity also, it has to check all those boxes for it to actually realize its long-term potential in India's net zero path. Thank you very much. I'll stop sharing.
Thank you so much. That was exceptionally interesting analysis. Let me just add one little question. I mean, you're rightly mentioning that the incentives for industries to change fuel from cheap coal to very expensive electricity is not there. And my question is, how do you see the role of biomass as a heat source for industry? Because transforming biomass into heat is associated with a much higher efficiency than transforming it to electricity. So rather than producing electricity and then using the electricity for provision of industrial steam or whatever, wouldn't it be more reasonable to use the biomass directly as a heat source in industry?
Yes, yes, yeah. So it's a very valid point. I think whether we are positioning it as an interim solution or whether we are positioning it as a long-term solution, that definitely matters a lot. And right now the debate is interim solution. It's definitely there in the sense that bio pellets and all, even the heat generation process, they can be used, maybe not 100% bio pellet based heat generation, but maybe, co-firing, something like that. That already I'm very sure many industries are doing, but they are viewing it as an interim solution as of now. Because first is cost. Let's say cost is cheaper, but then there is also about supply certainty and would a technology that is not scaled up in a very big way, does it create some kind of risk in the mindset of these investors who are operating these plants, right? Is there a risk in their mind that comes just from this thing that, okay, what if I invest in this and there is some big issue on the supply side 5 years down the line? Now that's a risk. So the question is, investors are all, it's not just about that cost at that point of time. It's also about what is the risk framing around a particular technology that will, guide decision making in industrial investments. Yeah.
Yes, thank you very much for that addition, and I completely agree. Supply security is one of the really critical issues when you think about bioenergy. That must be part of the game. With this, I would like to ask Mr. Ashok Kumar Rajput to talk to us. He is ex officio additional secretary to the government of India and responsible for the Central Electricity Authority in the Ministry of Power. Please, Mr. Rajput, share your views on the future of bioenergy use for power generation with.
Good morning or good afternoon, everybody. Namaskar. I am A.K. Rajput, as rightly introduced. I am a member Power Systems with the Central Electricity Authority, Ministry of Power. India needs energy, and so also the other countries of the world needs energy. And as far as we are concerned, or the human being is considered, there is a need of energy and we utilize it in a most judicious manner. So similarly, we have to generate the energy taking a combination of all the available resources. That includes the coal-based, the nuclear-based, the hydro, and other renewables. In this direction, in the field of electric generation, the use of biomass pellets or the biomass as a direct source of the heat is worth noting, I would say. It can be promoted, but the care has to be taken that supply chain is maintained. Biomass has applications in increasing the fertility of the soil in a natural way. That aspect we should not forget. And in this, and in this direction, we alone as the power professionals cannot maintain a balance. We have to take help of the general masses. So we have to take the help of the general masses. Those includes the less people with less formal educations and spread over all over the territory where the biomass can be collected. And as we all know that the nature has different phases. One phase is that the rain might take place, and during the time if the rain is there and if your biomass is available, and that biomass will be available in the wet form. So energy content, it will affect the energy content. And if you store that particular biomass, it will further lose its energy content, and there will be so many contaminations also. Fungus may grow, other microbes may also grow. As far as pellets are considered, pellet making is basically a refinement of whatsoever the raw biomass is there from different sources, say husk and others, saying paddy waste and other waste, and other crop waste or the maybe the waste from the trees, which are say early going trees, fast going trees, and in our terminology, when we talk of the electrical engineering and generation university, we call them the power crops. So those who are into the agriculture and the business of the power and make it as a business model, they very well know what are the power crops suitable for a particular geography and the climatic conditions. We also have the biodigesters. Not only the pellets, but the biodigesters are already there, and those biodigesters, whatsoever the energy content or the gases comes out of that, those have been utilized for generation of electricity. Some of the research projects have also been undertaken by Ministry of Power under this, in which at least two universities joined, one for development of the biodigester and one for development of the power crops. Research on the power crops, type of the soil, less water, but growing or increasing the biomass at a faster pace, utilizing it, and doing the digestion process, and through the digestion process generating the electricity. That is one way. Another is when we are having sufficiently dry or a lesser moisture content, we can go in for pelleting. But in case of the pelleting also, transportation is one of the issue because it requires huge volume. So you have to you have to have a large lorry or the truck to carry the same volume or the energy content, say as compared to the coal or as compared to the petroleum products. So that is one comparison that has to be seen. It has to be made available locally near the power plant or near the electrical machinery, thermal power based machinery, where it could be utilized. Another competitor in this is the waste to energy, municipal solid waste, and the development of energy. That is also of critical applications because many huge dumps are getting created and they are become the social hazard as well as the health hazard. and many times the uncontrolled fire also took place. So this is another form, and we have to keep in mind that how the just transition can take place. When we say reducing the dependency on the coal and coal as a source of energy, which so far has been the prime source of the energy insofar as the electricity generation is concerned. You take the example of railways. Railways earlier, the locomotives were the coal-fired ways, and it's the sense of, you can say, efficiency and the environment and the social considerations, and efficiency in terms of the power, efficiency in terms of the transportation and the speed and the volume. It took it They took a transition to the diesel locomotives, and then now to the electric locomotive. So it's an established fact that when the electricity is generated at a centralized place by whatsoever the source is at a mass scale, running the trains or running the metro rails or running the public transport EV buses, that is more clean as compared to the other uses. One more consideration has to be given that when these pellets are being used as a mixed and co-firing with the coal, there is no incentive that what quantum would be termed as the RE, renewable energy. Because some portion you are say 5% or 10% as per our boilers are considered in India, those boilers are designed for say 5 to 10% of the consumption of the pellets. And in those boilers, say about say 5%, when we are putting in the good quality of the pellets with the coal, so they will be contributing in lesser consumption of the coal comparative to the whole consumption of the coal, and some amount of whatsoever the renewable energy is there, that method need to be developed and that method need to be certified and should be universal for all, so that they get the incentive to utilize the pellets, so that this biomass pellets are use is promoted. And whatsoever the biomass is there, it is basically availability is seasonal in nature. Most of the biomass, they say after the crop is over, and whatsoever the crop residue remains, that has to be collected, stored, processed in the form of the various type of the various types of the pellets. There are some of the pellets which can be used directly for the co-firing of the in the thermal power plants or as a source of heat, and there are also the pellets which can be used in place of the electrical heaters or the kerosene based stoves, and they are also good source of energy, and this they create lesser pollutions. So power crops I have mentioned. So there is a lot of research and development needed in generation of the power crops. Maybe the steered one structure on the say hilly terrains, and that one there the power crops can be developed, which requires the lesser amount of water. As far as energy transition is concerned, that is the another aspect. It's not that we keep on pushing use biomass and biomass itself, and end use economization of the energy is a must. We call it the load management or the demand side management. Energy efficiency and certain incentives in the form of the tariff are helpful in this. But when the need is there, need overpasses, it is a certain fact that the need and the urgency overpasses the economic incentives. Suppose if it's too hot and we need some comfort in the form of the atmospheric treatment or say heating and ventilation and air conditioning, we sometimes forget or we have to forget in terms of the comfort and the need. Distributed energy resources utilizing various sources of the energy, that includes the biomass and the other sources also. That is one of the form where it will have the more impact as compared to if it is goes to the higher capacity central thermal power plants and others. Reason being the distribution lines, they runs at the LT voltage level or the low voltage level and causes lot of losses in the system. The whole electricity passes from the central generating stations to the point of application. The losses are more, the burden on the lines is more and hence the losses are more. Meeting the loads, meeting the demands at the local level through the use of the distributed energy resources is one such solution. Another thing is that solar street lights can be used, and for quantification and incentive that whatever energy source we have generated and from where we have got the electricity, pure electricity, we need to have the proper measurement and indexing. That this is the method and I have used, and through this way I am getting a judicious incentive and the correct way of incentive. We also need to analyze the performance over a time. It's not that initially say for 1 year or 2 years the performance of electricity generation through these sources is good, but later on with the time it degraded. So life of the generating system using these type of the resources is a must. Sometimes cell combustion also took place in terms of certain type of the biomasses if they are not cared and stored properly. Cogeneration is very prevalent in India. Need there is that we have to do and conduct the energy audit and see that what benefits could be arrived at and how that particular energy efficiency could be increased. So cogeneration, say sugarcane is one of the major crop in certain parts of the India, and from there whatsoever the biomass is coming is used as the cogeneration. And say there are research also going on how to preserve these biomass and to see the effect. Say you are purchasing a biomass with a certain calorific value, but with the time it loses the calorific value. So certain compensation has to be given, and the utilization cycle has to be that. Say that the efficiency degradation or the energy content degradation of the biomass is not there, and it is utilized in time. So it is the economic utilization of the biomass that also matters. And as it is very obvious that the supply chain is very much required, what new sources of the biomass could be there which could give the early returns or the early produce. And another factor is that the seasonal availability. And now everybody is asking for the biomass. So whether the power requirement or whether the hydrogen production requirement and whether the other gaseous based projects or the methanol based product requirement, from where that much quantity of the biomass will come, that need to be ensured. And so there are many takers, source is limited. It cannot be, say biomass cannot be generated all of a sudden, or it cannot be dig out all of a sudden like the coal, so that you increase the coal production by deploying more machinery and more number of manpowers. It takes time. That aspect we should not forget. And we should not forget that it will be available round the clock 24 by 7 whenever you want. Whenever say some collection takes place, it's very clearly understood that only the during the daytime when the weather is not so harsh, the rains are not there, then only the biomass collection can be effective. So these are certain views, and naturally I would be happy and rather I am lucky that I am among this group, those who are experts in this, and I am listening to them. Thank you.
Thank you very much, Mr. Rajput. Uh, I think with this, we will move to our next speaker. And I would like to welcome Yashu Kawat. He is member of the CII Industry Working Group on Biomass Co-firing. So please explain to us what your group is doing and how you're trying to contribute to the development in this sector. Floor is yours.
Okay, thank you and good afternoon. First, I will introduce myself. I am Jasu Kawad. I am from DCM Sriram Group, and we are having a captive power plant of 240 megawatt, and I am adding the power plants. And I am also the member of CII working group. And CII purpose of this form the working group is to identify the challenges for co-firing of biomass with coal in thermal power plant as well as captive power plants. So our aim is to identify that challenges and how to overcome by technology or by government policies to facilitate the end users and maximize the biomass firing with coal, mixed fire with coal in power plant as well as captive power plants. Can you share the PPT? Bhaudaj? Yeah. So, CE Working Forum for Clean Air. There are number of industrial members who form the groups, and we are working to identify the problems facing what is various challenges facing for co-firing with coal. Next slide, please. So these are the working group member of various industries like JSW, Energy Emplo, Energy to Power, L&T, Tata Chemical, DCM Sriram, from where I am coming, HEL and ICF. All these members are working together to find out the challenges. Next group, next please. Yeah, working group activity, I will brief you. This forum group was formed in January 2024. Purpose I already discussed. The working group creation under the India CA from is 9 industrial members are working on this group. In February 2024, first meeting, we can say kickoff meeting was held online with all the stakeholder, and all members have discussed uh, highlights and challenges of biomass firing in power plants. Third activity was bilateral consultation with industrial member in March and April. So bilateral consultation with industrial highlight the needs of detailed assessment and plant specific issues. Issues like already you might have discussed that right now so many captive power plant are using biomass co-firing in range of 2% to 25-30% up to, but they are not getting the credit of renew power or RE category. That is also challenge, and even though there are other challenge also, but they are firing, but they are not getting any benefit because of lack of policy and lack of other infrastructure. In May 2024, our group has visited 2 power plants to interact with end users team. What are the practical limitations and challenges in firing? Next slide, please. Yeah, activity planned ahead is the detailed financial assessment. Like every the old installation power plant don't equip with co-firing facility like infrastructure as well as feeding system. So business viability of biomass conversion, especially those old units, how to convert this into, because they are not designed as per biomass firing, because they all the plant are designed for 100% coal fire plant. So we have to mix with the biomass. So there are some design modifications, some infrastructure requirement for co-firing, financial implication of biomass firing, because there are so many financial implications like to create the infrastructure for feeding, staking, unloading, and storage. Second is the when you fire the biomass with coal, obviously the auxiliary power consumption will be higher because biomass required high air consumption compared to coal. And when we go for higher air consumption, there will be efficiency loss in boiler. So that financial implication we have to work out as a group, and we will present to the government for policymakers. Multi-stakeholder workshop we are planning to do to create the roadmap and sustainable utilization of biomass in power plants, and policy advocacy. After doing all this work, we will come out with a clear roadmap on terms of infrastructure, in terms of technology support, in terms of government policy that we will represent to government for policy making, so that all industry can encourage for biomass utilization and contribute toward the CO2 emission reduction. Because biomass earlier that was discussing that biomass availability storage in is the bigger challenge, and they incur huge cost compared to coal. So every users has to incur more money to firing the biomass. That cost needs to be compensated in form of any form, either policy or some uh, mm, uh, relaxation in taxes like that.
because where to pass on, that government has to decide. Next slide. Yeah. As a users, I am working in DCM, and we are having a 241 megawatt captive power plant at Gujarat location, Bharuch district. So we have a 3 units power plant. Two is CFBC and one is PF fire boiler. So till date, we have sustainably achieved 20% of biomass firing in CFBC boiler in form of briquette, as well as loose. Loose we have achieved 3 to 5%, but because of loose biomass having their volumetric limitation, the storage, feeding, and bunkering is the major challenge because design is for 100% coal. So even though we are comfortably achieved 20% of biomass briquette consumption co-firing with coal in CFBC, our 2 CFBC boiler. So major challenge of biomass firing, because these boiler are not designed for as per biomass firing, because biomass having a higher chloride content and higher alkali matter, which create the fouling problem as well as high temperature corrosion. So we have kept limited to 20% because of this design issue. If we want to go for beyond the 20%, that high temperature corrosion as well as alkali metal fouling, that needs to be care of in design stage itself. Otherwise, it is very difficult to run one old design boiler with more than 20% of biomass firing. And old installation don't having a separate storage, unloading, as well as separate feeding system in boiler. So that is also big challenge for the old installation, because mixing with coal is the one of the solution, but it is not a sustainable solution, because the both solid fuel having a different property, biomass having a very high VM. So there are chances of spontaneous combustion. So we need to develop the infrastructure for specially storage, because biomass availability is a seasonal. In monsoon, it is very difficult to get the biomass. So for the monsoon period, if you want to run throughout the year, you have required huge covered storage to store the biomass. Otherwise, it will degrade. And there are, because of high volatile matter, there are very huge high chance of spontaneous combustion or fire. So to meet this challenge, we have to create the infrastructure to fight the to mitigate this type of risks. So it will always cost huge infrastructure is required in terms of capex. uh, uh, then we come to OPEX. Definitely, raw material cost, pellet and briquette is always higher. Briquette is at par with coal, but pellet is higher, 20-30% higher cost than the coal. So always there is that the cost will pass on to power generation cost, and definitely power generation cost will increase. Loss of plant efficiency because of your dry flue gas loss will increase. Auxiliary power, again it will increase. That will be again loaded in the power cost, and power cost will be higher. Additional maintenance cost because of this corrosion and fouling. You have to face, we may have to face the force outage or unplanned outage of boiler. That also that cost also will be included in this OPEX cost. And we have not tried in our PF fire boiler 2 to 3%, up to 2%, 3% we have tried in PF fire boiler, because we have a pressurized roller mill, and the mill inlet air temperature itself is 250 to 80 degrees temperature. So there are chance of biomass burnt and explosion. That's what we have limited to biomass firing for CFBC boiler, not in PF boiler. Next slide, please. So key idea till date we have discussed and various forum and interaction with various stakeholder. We found following are the major challenges in biomass co-firing in power plants. Uh, Seasonal procurement and raw material, rice straw, because it is the seasonal availability. When crop is after harvesting, we can get only the biomass, otherwise not. Then lack of transportation, because power, mostly power plant are located at remote place, so it is far away from the agro waste generator. So transportation cost as well as collection and uh, uh, because biomass sector is also one of the unorganized sector. So collection is the challenge. After collection, there is the transportation to users, end users. This is also a challenge because biomass having a volumetric limitation. So truck loading is the also big limitation. You cannot load more than certain volume. So weight wise is less, but volume wise is the very high. Then pellet and supply to the power plant is a wide range of distance varying that already discussed, and the pellet itself is the making cost is very costly. So anyhow, this cost needs to be compensated to end users any form, either subsidy or policy or taxes form. Biomass co-firing, biomass pellet quantity included the hydroscopic nature that are the itself the characteristic of biomass which lead to the difficulty in challenges in operation. High volatile matter, there are chance of spontaneous combustion. Low ignition temperature, again it leads to the spontaneous combustion. Biomass dedicated management system equipped with fire and methane gas detection. That is why infrastructure existing setup have to install this type of setup for sustainable operation. Biomass being highly volatile, fire safety is major concern because in storage, if you require separate storage system, if you store it with coal, there are more chances of combustion. That is the major challenge. Impact of station retreat, as earlier I have discussed that it will reduce the boiler efficiency, auxiliary power consumption. So ultimately, it will impact on overall station retreat. This is my last slide, and this is the presentation from my side.
Thank you so much. That was extremely interesting and very much already addressing the technical issues. Let me just make one suggestion. In Europe, we have been using biomass co-firing in power plants for the last 15 to 17 years. And there is a lot of the experiences that you are describing have been made here, including the fire safety issue, which keeps coming back, and so many power plants had issues with that. So I think there is a scope of international cooperation in that field. And we as WBA are very happy to facilitate that. We know all the industrial pellet users in Europe that are co-firing. We know the experts that have been all the laboratory work to assess the slagging and fouling issues, et cetera, et cetera. And I think it's worthwhile to get into contact and to share experiences because there is quite a bit of experiences available here now already with some 15, 17 years of operations running in this field. So we're very happy and open to cooperate with you and to facilitate an exchange in this field.
Thank you. Thank you for support. And I request our coordinator to arrange interaction with the European part.
So may I ask you one more question that was raised from the audience, and that is, according to your experiences, what type of agro feedstock is most convenient for high co-firing rates?
Definitely, I am coming from the region is the western part of India. So groundnut shell is the most compatible fuel, having a very less VM as well as very high CV. So is the most compatible fuel biomass is the groundnut shell.
That's interesting. Yes. I mean, the experiences we have here is the more woody the biomass is, the more convenient it is for combustion. And the more leafy it is, the less less suitable it is. Very well, ladies and gentlemen, we are approaching the final part of our webinar. We have just a few minutes more to go. and I would like to ask the panelists to make a short summing up statement they would like to put at the end of this webinar. So may I ask Mr. Sahi to start with? Let's move over to Mr. Datta.
Thank you, everyone. It was a great insight to hear from us, and also an insight to share our experience. We are one of the best solutions. We always feel we have optimized the challenge, and we look forward to hear from you. We have the best of technologies from Europe, and I look forward to see a lot of prioritization happening along with biomass power energy. Thank you so much, everybody.
Wonderful. Thank you. Now it's Mr. Sahi. Please unmute yourself. You're still muted. Okay. We'll move over to Mr. Rajput.
Yes, already I have spoken. Do I need to tell something more? And hello.
Yes, just a summary remark.
Summary. In between came the issue of bamboo. I'm not an agriculture expert, not a social activist. The bamboo has many applications. We should be careful. This is my totally personal view. We should be cautious in use of bamboo in the form of pellet or any form of direct burning. Particularly if in India, it has got, majority of the population has got religious attachment to it. That as a social belief, religious belief, which have the scientific facts also behind it, and those could be ascertained. We should not burn bamboo at all. We have carried out, or I in personal capacity have carried out some small analysis with my group. Bamboos, if they are retained and kept attached to the ground, they are quite useful in arresting the high speed flow of the water because of the heavy rains. They retains the soil, the loose soil of the hilly slope, and help in controlling the soil erosion, that the deep soil erosion through the cut method, and also the surface erosion of the soil. If that soil comes with a speed onto the roads and onto the rivers and onto the living areas, habitations, the disaster is going to happen, particularly during the heavy rains. And after that, you don't have much time that the plantation or the vegetation or the strong roots, because the bamboo has also got the strong roots, and when the water will flow through the group plantation of the bamboos, it will slow down its speed and it will come in a controlled way. Bamboos naturally for food for the local people in the raw form, in the raw or the semi-grown form, the food for elephants. Because what happens when on the hilly slopes, the bamboos are there, the elephants are also there. So that is one. Bamboo has many applications in India. Not to mention, you may or may not like it. When a person died, you need for the funeral the bamboo platform, that the bamboo one.
Thank you very much.
Yes, and one more thing is there. The bamboo has many other applications as far as socio-economic upliftment of the countryman is considered. Not very high skill required. They can prepare the basket, they can prepare the furniture, many wooden articles, many wooden houses are also there, and many beautifying articles are there, which fetches higher value and also retains the sustainability. So it's basically a just transition in that form rather than cutting the bamboos in mass scale. So research and development along with the scientists who are dealing particularly with the agriculture and the chemical scientists who can study that how much harmful content or particularly the heavy lead it emits into the atmosphere. That is a must for doing such type of the analysis.
Thank you very much,
Maybe,
Mr. Rajput.
maybe in biodigesting form we can use, and we have to turn our wheel, or we have to turn our direction to other application rather than the pellets. That's my
Thank you so
submission.
much.
Thank you.
Thank you so much. We have to wrap up. So just one sentence to Mr. Chaturvedi, please.
Great. Thank you. Thank you for this opportunity. It was great listening to all of you. I think the only thing I want to say that we should acknowledge that bioenergy at this stage in the power sector, it does need policy support. It is not at that level where it can outcompete other technologies. So it needs policy support. That is very clear. Whether government and to what extent the government is able to provide that policy support, it depends on many factors. The government will view which technology is best placed to provide these other benefits like economic growth possibilities, manufacturing possibilities, employment creation possibilities. What is the fiscal space? So there are many, many factors which will uh, push the government on this side or that side of like technology choice, so to speak. Yeah. So the interaction in both is very, very important. Thank you so much.
Thank you very much. Mr. Kabat, would you like to share some final observations with us? Does not seem to be the case. Ladies and gentlemen, thank you very much for joining our webinar. I would like to point out that we have two more editions of our Indian series of webinars coming up in the next months. You will all be invited and informed to join these webinars, and we're very excited to have this debate about the very, very exciting development of bioenergy in India. Thank you very much. Goodbye, and hope to see you soon again.